So now we're going to move into a new piece of stoichiometry for those of you in advanced chemistry. Actually, it's for everybody, even in general chemistry, although advanced is where we're starting because of my absence on February 7th. So if we have a stoichiometric equation like this, say suppose I'll use that same one I've used. Whoops, don't do that. So 2 ALs plus 6 HCl yields 2 AlCl3s plus hydrogen. So I'm just making up this equation. You'd have to have 3 hydrogens there. What we did in the previous video, I said, well, what if you had, say, 25 moles of this, and you wanted to know how many moles of that? So you would do 25 moles of HCl times moles of HCl on the bottom, AlCl3 on the top. So you'd have 2 AlCl3s and 6 HCl. I got those numbers from up here. Moles of HCl would cancel. Moles of HCl would cancel, and I'd end up with 50 divided by 6. So then you'd pull out your calculator and you'd say 50 divided by 6. And that would be your answer. Okay, so what if instead of having the moles, what if we were given grams instead? So what if instead of the moles it gave us, we said, oh, what if we have, say, 73 grams of this? And we'd like to know how many grams of that. Well, your first inclination might be to do this: 73 grams of HCl times, and you put grams of HCl on the bottom. You put grams of AlCl3 on the top, 2, 6, but that will not work. The reason it doesn't work is that chemical equations tell us relationships between numbers of things, not what they weigh. So if you watched the previous video, I used the analogy of the brass quintets. And if you have a brass quintet, I might have used a string quartet. Anyway, if you have a brass quintet, there'll be 5 players. When you want to form a brass quintet, you don't say, well, I'm going to go out and find about 1,000 pounds of brass players. You find 5 brass players. And what they weigh is kind of irrelevant. And another example would be dating. Suppose you were going to, if you're a guy and you're going to take a girl to homecoming, do you go out and look for about 120 pounds of girl? Or do you look for one girl? So you look for one. It's a stoichiometric relationship based on numbers of things. So fortunately, we have a unit that deals with numbers of things, and that would be moles. So we're going to take our 73 grams of HCl and change it to a number of things, not a mass, but a number of things. So you put grams of HCl here, you put moles of HCl on the top, and then 1 mole is 36.5 grams. Now I get the 36.5 by adding up the weight of 1 H and 1 Cl. So that gives me then 2 moles of HCl. Then we take our 2 moles of HCl, moles on the bottom, moles of aluminum chloride on the top, because we're looking for aluminum chloride, remember. So now we know there are 2 of these for every 6 of those. So that gives us 4/6 or 0.67 moles of aluminum chloride. Then if we take our 0.67 moles of aluminum chloride, we're going to change that back into grams now. Okay, so we know the moles of aluminum chloride, and we know how to change grams to moles. So you put a moles of aluminum chloride down here, and you put grams of aluminum chloride on the top. 1 goes with moles. 1 always goes with moles except in this mole ratio step. Okay, so you pull out a calculator and you add up your aluminum chloride. So I'm just going to do that on my phone. It would be 27, which is aluminum, plus 35.5 times 3. So I get 133.5. So now we would multiply the 133.5 times 0.67, and we get 89.4. So that'd be our final answer, 89.4 grams of aluminum chloride. So there's an algorithm for these problems. An algorithm is a process that you go through that you just repeat that system. It's a system of solving for them. Number 1, change to moles. Number 2, after you've changed to moles, you're going to use the mole ratio. And then number 3, after you found the mole ratio, you change back to your desired unit, which often is grams. It doesn't have to be grams, it might be liters. All right, that's the basic algorithm. Now, of course, what if a problem here said you have 10 moles of that and you wanted to know how many grams of that? Would you need to do the first step of the algorithm? No, because it's already in moles. So you don't have to change the moles. It already is moles. So you wouldn't have to do that. So you take your 10 moles of HCl, put moles of HCl there, and then put moles of what you're looking for on top. Now you still would need to change moles to grams. So we'd have 2 and 6, but that's moles of HCl. So you still have to do the third step, which is use the moles of AlCl3 on the bottom and grams of AlCl3 on top, and 133.5 is 1. So then you go ahead and do that math. 10 times 2 times 133.5, and then divide by 6. I won't work that out because I think we all know how to do that. All right, so 3 steps in a general algorithm. Here are the 3 steps. Change to moles, use the mole ratio, change to the desired unit. Do you always have to do all 3 steps? It depends on what the problem tells you. If it's already in moles, you don't have to do the first step. Or if it gave you grams and asked for moles of something else, then you do the first 2 steps and not the third. So you're going to have to think a little bit about that as you do the problems. All right, I'm hoping one example will be enough to get you going on this assignment. You may have to work together in class on Thursday or on Tuesday, but I'll leave a template for you and put the link on the homework site that you need to go to make this happen. So that'll be it for on this video. Maybe I might have time to do one more example. All right, here we go. This is it for this one.